Here we have a 3-terminal fluorescent capacitor transformer. On the end here, I soldered a wire onto both of the terminals on there, and I insulated it with the rubber that you use to coat tool handles. You can either dip it or they have a spray for it. That insulates the end cap and the terminals. Now the other end, I totally insulated off. There's nothing connected to any of these terminals here. To test this, I used a sandwich bag and put a rubber band around it to insulate off this end here. So there's no connection directly to the gases inside to the one terminal on the end. The connection is all by capacitance through this wrap that I have on here, which is copper foil tape. It don't necessarily have to be that. You could use the regular aluminum insulated tape. But this end here, I used the aluminum tape and I left the wax paper on the inside. So now I can adjust this. It's variable. I'll get this set up and show you how it works. I have a stand here to do a spark gap on the copper tape, but you can also get kind of a non-sparking gap through this foil end here. It'll be real fast. It'll actually arc like a capacitor, or a capacitance type of arc. You don't even see any discharge. And what I'm using, I don't have a Slayer exciter, and this isn't quite enough to totally light this bulb, but this is an ozone generator air purifier. Forgot one wire here. So I'm connected up to this wrap, which is on the outside. This is also sharing the same outside surface, but yet it's lighting gases in there without any connection. So we got a one-wire connection. And you probably can't see it, but there is a small arc there, and you can vary it. So you can vary the voltage by sliding it. You can also vary frequency. So you have one terminal on the end, you have the other terminal here, and this is another terminal. There's something I noticed with this. If you think about electricity, the velocity of electricity traveling through this tube to get a capacitance off of this one, you have a voltage that's occurring now between two different points in space and time, if you think about it. The other thing I noticed with this, the amount of surface area you have here, you can also vary the voltage. Like, you have so much surface area here and so much here, you can bring the voltage up or down. Now the other interesting thing, I don't know if you'll see this, I can touch this here and I'm not getting shocked. We only have 3 terminals, the one on the end and these 2 here. But if I get a good grip on here, you might see this, I got a 4th terminal. So evidently you can add as many terminals for a capacitor on this as you'd like. And I would imagine a longer bulb will give you more capacitance. Something a little out of the ordinary. I don't have a whole lot of experience with high voltage, but I'm sure some of you might know a good use for this. Maybe one an earth ground connection and the other one going to the Slayer exciters. I think this would be a good way to incorporate the earth ground. I added some more terminals on here. These two I joined together. I tried doing two totally, I guess I should warn you about that. If you touch any connection across this bulb, any two connections, you're going to get hit with some juice. I've done it many times by accident. Anyhow, I tried to do two totally isolated and I didn't get anything on the bulb. The isolated spark gap connection can become the common. So you have to have one connection with the spark gap section, and then you can use another terminal to operate the light bulb. One thing I noticed with this, whenever you move this, the variable part, every time that arcs, these terminals clamp down on the bulb and stop you. Thanks for watching.